Hello, this is Lonnie Haynes. I'm going to be talking about the area of operation technical subject area, Task A, aircraft flight instruments and navigation equipment. And I'm just going to give a brief overview of the elements, and for an in-depth coverage, you can refer to FAA-8-8083-15, and you can find that book, hard copies, in bookstores or uh, pilot material stores, and you can get it online at FAA.gov. So as a brief overview of what I'm going to talk about, we'll talk about pitot-static systems, altitude indicators, heading indicator, uh, horizontal situation indicator, radiomagnetic indicator, magnetic compass, turn and slip, turn coordinators, electrical system in general, vacuum system in general, electronic engine and instrument display, primary flight display, uh, VORs, DMEs, ILS, marker beacon receiver indicators, ADFs, transponders, altitude encoding, electronic flight display, global positioning system, autopilot, flight management system, multifunction display, and anti-icing of the airframe, propeller, air intake, fuel system, pitot-static system, and onboard radar lightning detection systems, and other in-flight weather systems. So with that, the pitot-static system. The general pitot-static system is consists of a pitot tube, and most of the time there's a heated element in the pitot tube, anti-icing element. And the pitot tube and the static port, and there will usually be an alternate static source inside in case the normal static port is blocked by ice or mud or whatever other thing it may be blocked by. There's a source inside the cockpit that the pilot can change to get an alternate static source. But inside the cockpit, the pressure that you get is going to be in error a little bit, and this usually will be in error to make it look like you're higher than you actually are. And then, as part of the pitot-static system, we have an altimeter, an altimeter, which is, they call it a sensitive altimeter, and you set your barometric pressure, of the airport pressure before you take off, and a vertical speed indicator, which is an indication of how fast you're climbing or descending, and an airspeed indicator. And notice that the altimeter and the vertical speed indicator are only dependent upon static pressure, whereas the airspeed indicator depends both on static pressure and pitot pressure. So as you get up higher and the air gets less dense, the your airspeed is corrected for that less density, by that reduction in density by the instrument itself. The altimeter, this is kind of a, you got a knob over here that you set the barometric pressure to. In this case, it's set to 29.92. And as far as the operation inside the unit, it's taking pressure out of the static port and pumping it, or it's going into the device, and that pressure causes that aneroid to expand or contract, which moves the little dial here and makes the needle move around. And this is a very simplified diagram, but it's just the functionality is what we're looking for. I've torn these up before, and I can attest that they're very much more complicated inside than what's shown in this diagram. The airspeed indicator, you've got, first of all, let me talk about the dial. VSO, you've got the flap extended stall speed, and then the bottom of the green is the no flaps stall speed. The white arc is the flap extended speed. So before you operate the flaps, you want to be within this white arc. The green arc is the normal operating speed, or the normal operating speed. And then the yellow arc rather, is the caution speed. You don't want to operate the aircraft in turbulent conditions in the yellow arc. You can operate, if it's smooth air, you can operate in the yellow arc. But as a general rule, you should be very cautious to operate the aircraft within the yellow arc. And you don't want to do it at all in turbulent air. And then the red line is the never exceed speed, which structural damage, if it's turbulent air and you're in the yellow arc, structural damage can occur to the aircraft. And beyond the red line, structural damage can also occur. And if you look, as the functionality of the unit, it's getting static air pumped into the case, and then pitot air pumped into the diaphragm, so that diaphragm is expanding and contracting against the pressure in the case. So the combination is correcting the airspeed for the different air densities at different altitudes. Okay, vertical speed indicator, VSI. First you got the dial here, 500 feet up, 500 feet down, 1,000, and etc. And the way that operates is it takes static air and it's going to operate this piston, which then operates the diaphragm and turns the indicator. But this piston here is operating against the case pressure. There's a restricted passage here. I've heard it called a calibrated orifice, and it slowly leaks. The acceleration pump is operating against this, is operated by the static pressure, and this restricted passage is slowly calibrated release of the pressure inside the unit, such that when the pressure is not changing, this thing will go to zero. If the pressure is increasing, for example, it pushes this dashpot piston up, in which works this diaphragm and makes it go up. And bottom line is, when everything's equalized in here, this thing goes to zero, and that. So anyway, there it is. Attitude indicator. Okay, attitude indicator. You've got a roll indication in 10-degree increments, and then the 45-degree increments marked in 60 degrees, and you've got a climb or descend indication. And this line completely across here is the horizon line, and this little diagram here is the diagram of the aircraft wings. So when this thing is right on the horizon line, you're straight and level. And when this thing is banked, then you're turning, or when in the picture here, you're in a climb. You're in a 10-degree climb. Okay, heading indicator, HSI and RMI. Heading indicator is just shows heading. It's a very simple instrument. And a HSI will show heading, and it'll also show like a VOR indicator. Like in this case, your two front pointers pointing to the VOR, if this is a VOR that we have tuned in here. The VOR in this case would be 300 degrees off the nose, and you'd actually be left of the VOR line in order to, and actually, and you'd be on the the 120 degree radial, pointing toward the VOR to the left of the 120 degree radial. So you need to fly right to be right on the radial. And you got to mention your heading here would be